We have discussed what a TCP. TCP is a transport layer protocol, and this protocol offers a reliable connection or reliable service to the processes in the application layer. And we have seen the connection establishment process, what we called as three-way handshaking, and what are the transport layer primitives in our previous session. Now we will discuss the later is the remaining sessions of TCP. Before using a TCP or before a data transfer, a TCP connection must be established between the sender and receiver. There are two endpoints to this connection or a connection. Before data transfer, a connection must be established if we are using TCP between two endpoints, and these endpoints are called as sockets. So there will be a socket at the sending side and there will be a socket in the receiving side. TCP connection can be established between these two sockets. So what is a socket? Each socket can be described as endpoint. And how can you identify a socket? A socket has a socket number consisting of the IP address of the host and a 16-bit port number. So a socket has a socket number consisting of the IP address of the host and a 16-bit port number. Okay, the port numbers, for example, port numbers 21 can be used for FTP and 23 for telnet. These are port numbers. Port number 21 means we are using FTP. If the port number associated with a particular socket is 20, then that socket has been created for telnet. So each socket has a socket number consisting of IP address of that machine with a 16-bit port and port number. Port numbers are normally used to identify the services, that we are using. To obtain TCP service, a connection must be established between sockets. Okay. All TCP connections are full duplex and point to point, which means that in TCP, server machine and client machine can transmit data simultaneously and are point to point. Also, TCP connection is a byte string. Every byte on TCP connection has its own 32-bit sequence number. So every byte that is sending on a TCP connection will have a 32-bit sequence number. In TCP, data is exchanged in the form of segments. A segment consists of 20-byte header plus an optional part followed by 0 or more data bytes. Okay. Now we are discussing about the TCP segment header. The TCP segment header will contain source port, destination port, sequence number, acknowledgement number, TCP header. Then we will discuss about this URG, SEK, PSH. The last six fields are important. And we will discuss this window size, checksum, urgent pointer, options, and followed by data. So this is this 1, 2, 3, 4, 5. The first 5 rows are the mandatory header fields. Each row will contain 4 bytes. Then these 5 rows will make it as 20 bytes. 32 bits means 4 byte. Here 4, 4, 4, 4, 4. 5 rows make it 20. So the first 5 rows contains 20 bytes, followed by this option field and followed by the data field. This is a TCP header, and we will see what are the fields. Segments without any data are legal. Segments without any data, which means this is called a segment. A segment contains this header field, an optional field, an options field, and data field. This field may or may not contain data. So segments without data is valid, and that can be used for acknowledgement and control messages. Okay. Now, what is a source port? Source port and destination port. These two are the first two fields. Source port and destination port identify the local endpoints of the connection. As we say, 24 is for FTP and 23 for telnet. And see, this number identifies what type of service that we are using. If it is 21, then we are using FTP. If it is 23, then we are using telnet. Then sequence number and acknowledgement number are usually 32-bit long. Sequence numbers are used to identify the position or number of the byte, whether it is a first byte, second byte, or third byte, etc. Acknowledgement number is used to identify which byte or which segment is needed next. TCP header length tells how many. The next field is TCP header length. TCP header length. What is TCP header length? That field specifies how many 32-bit words are contained in the TCP header. So the length of the TCP header is specified by the TCP header field. The next 6-bit field are not used. Next 6, which means TCP header length specifies the length of the header in 32 bits or in 4-byte units. Length of the header. The next 6 bytes are normally not used, and the last 6 URG, SEK, PSH, RST, SYNF, these 6 are 1-bit fields. We will describe this field starting from URG. URG is set to 1 if urgent pointer is in use, which means this is an urgent pointer. If we use this urgent pointer is normally used to describe the urgent data. If there is an urgent data in this segment, then this urgent pointer will point to that urgent data. Then if there is some urgent data in our segment and urgent pointer is used, urgent pointer is present. If an urgent pointer is present in the segment, then URG will be used. URG will be set to set. Okay, if we use urgent pointer. Urgent pointer URG is set to 1 if the urgent pointer is in use. The urgent pointer is used to indicate a byte offset from the current sequence number at which urgent data are to be found. So URG pointer, urgent pointer normally contains a byte offset from the current sequence number at which urgent data are to be found. Okay. Urgent pointer ഉണ്ടെങ്കിൽ urgent data point ചെയ്യുന്ന urgent pointer normally ഒരു byte offset ആണ് from the current sequence number. അങ്ങനെ ഉണ്ടെങ്കിൽ urgent pointer ഉണ്ടെങ്കിൽ URG that field will set to 1. അപ്പോൾ URG field ഉണ്ടെങ്കിൽ മാത്രം urgent pointerലും urgent data ഉണ്ടെന്ന് നോക്കിയാൽ മതി. Next field is ACK1 means acknowledgement number is valid. If it is 0, it means segment does not contain an acknowledgement. Which means the next field is നിങ്ങളിതിപ്പോൾ തൽക്കാലം നോക്കണ്ട, നമുക്ക് ഇമ്പോർട്ടൻ്റ് ആയിട്ടുള്ളത് ഇത് 6 ആണ്. അപ്പോൾ URG എന്താണെന്ന് പറഞ്ഞു, അർജൻറ്റ് പോയിന്റർ ഉണ്ടെങ്കിൽ, ഇപ്പോൾ ഒരു അർജൻറ്റ് ഡേറ്റ ഉണ്ടെങ്കിൽ ആ അർജൻറ്റ് ഡേറ്റയെ അർജൻറ്റ് പോയിന്റർ നമ്മൾ യൂസ് ചെയ്തിട്ടുണ്ടെങ്കിൽ URG 1 ആയിരിക്കും. Then ACK means acknowledgement ആണ്. ACK ഫീൽഡ് 1 ആണെങ്കിൽ അതിൻ്റെ അർത്ഥം എന്താണ്? അതിൻ്റെ അർത്ഥം ഇതിലുള്ള അക്നോളജ്മെൻറ്റ് നമ്പർ വാലിഡ് ആണെന്നാണ്. ഇപ്പോൾ ഈ ഫീൽഡ് 1 അല്ലെങ്കിൽ ദിസ് അക്നോളജ്മെൻറ്റ് നമ്പർ ഇസ് നോട്ട് വാലിഡ്. അപ്പോൾ അതാണ് എൻ്റെ മീനിങ്. Then PSH bit indicated pushed data. PSH bit ഉണ്ടല്ലോ, next is PSH bit. This is PSH. What is a PSH? RST SYN FIN. We will describe PSH RST SYN FIN. So what is the use of PSH? PSH bit indicates pushed data. So what is the use of PSH? If the PSH bit is 1, then the receiver is requested to deliver the data to the application upon arrival and not buffer it. So if PSH bit is 1, the receiver is requested to deliver the data to the application upon arrival and not to buffer it. And PSH. Next is RST bit is used to reset a connection due to the host crash or some other reason. So due to host crash or some other reason, there is a need for, if there is a need for reset a connection, then RST bit is used. If RST bit is 1, then the connection will be reset. Then SYN bit is used to establish a connection. So connection request as SYN is equal to 1, ACK is equal to 0, and connection acknowledgement as SYN is equal to 1 and acknowledgement field equal to 1. So SYN is used to establish a connection and FIN is used to release a connection. Okay. SYN is used to establish a connection and FIN is used to release a connection. Then the next field is window size. So we have window size and options. These are the remaining fields: window size and options. Window size and options. So what is the use of window size? Window size field tells how many bytes may be sent starting at the byte acknowledged. So window size normally tells how many packets can be sent before getting an acknowledgement. If window size is 5, then you can normally send 5 packets or 5 segments or half 5 here. In transport layer we are discussing about bytes, segments and bytes. So in TCP, window size specifies that you can send 5 bytes before receiving an acknowledgement. So you should send 5, if the window size is 5, you should send 5 bytes and wait for an acknowledgement. Then checksum field is normally used for reliability, as we said earlier. Then the options field contains various options like maximum TCP payload it is willing to accept. So suppose a machine can specify the maximum payload length, maximum TCP payload it is willing to accept, how many bytes or how many a machine can specify the maximum bytes that can be received by that machine in this options field. Also window size can be specified in the options field, and whether the machine is using selective repeat or go back, and which protocol is, which sliding window protocol is being used. These options can be specified in the options field. UDP is UDP segment. UDP is user datagram protocol. UCP is normally a collectionless unreliable protocol, and in UDP there will not be a connection establishment before data transfer, and in UDP there will not be an acknowledgement mechanism. Hence it is called as connectionless and unreliable protocol, UDP. And in UDP also we use the term segment. UDP segment consists of 8-byte header followed by the data. UDP segment also contains 8. UDP segment consists of 8-byte header followed by the data. In TCP we have seen that header length is 20 bytes followed by options field and data field, but in UDP there are only 8-byte header field followed by data. UDP length includes 8-byte header and the data. UDP length field. This is a header of a UDP, source port and destination port. We have seen what is a source port and destination port in TCP. Okay, UDP length, UDP checksum. So what is UDP length? UDP length field includes 8-byte header and the data. So UDP length field specifies the length of the header, length of the UDP header plus length of the data. So both length of the length of the header and length of the data field are included in the UDP length field. Okay. UDP checksum includes a pseudo header. UDP checksum in UDP and TCP, checksum is calculated, and this checksum is normally included with the data. At the receiving side, the checksum is again recalculated and compared with the original checksum. If both are same, then which means that there is not an error in the transmission. Transmission error ഉണ്ടാവുകയാണെങ്കിൽ, if an error has occurred during transmission, then that checksum will not be correct or checksum will not be equal. So UDP normally calculates checksum by using a pseudo header. We will see what is a pseudo header, then UDP header and the UDP data, then padded out to even number of bytes. UDP checksum. UDP normally calculates the checksum by using the pseudo header, UDP header and UDP data, and later it is padded out to even number of bytes. Okay, you can see TCP header. So to calculate the checksum, UDP uses this UDP header plus UDP data, and then this is a UDP pseudo header. This is a pseudo header that has been used by UDP to calculate the checksum. This pseudo header contains source address, destination address, then this field, then protocol number is 17, and UDP length. This is the length of the UDP header and data. So all these fields are used in the calculation of checksum, and hence it is called as pseudo header included in the UDP checksum. So UDP calculates checksum by using UDP header, UDP data, and then this UDP pseudo header. Okay, so this is the header of UDP. Okay, thank you.